Hello everyone, myself M. Preeti Ram, working as an assistant professor in the Department of Computer Science and Business System in Ramco Institute of Technology, Rajapalayam. Today we are going to see about the topic linked list in data structure using C++. So in computer programs, we often need to store and manage many items such as numbers, names, tasks, files, and messages, etc. The simplest way is using an array, but array have serious problems. Linked list was introduced to overcome the limitations of arrays. So what are the problems with arrays? In array, we have the following problems such as fixed size. Once declared, size can't grow or shrink. So next one is memory wastage. If size is large but used less, memory is wasted. So next one is insertion slow. So shifting elements is required. And then deletion slow. Again shifting is needed. So last one is continuous memory needed. So not always available. Let's see how these problems are solved in linked list. So how linked list solves these problems? Linked list uses dynamic memory. It grows or shrinks when needed. It stores the elements anywhere in the memory. Easy to insert or delete the nodes. No shifting is required in linked list. Let's see an real-time examples. So first one we can see train compartment system. Think of a train. Each coach is equal to one node. Each coach has passenger data, a link to a next coach. So in adding a new coach, if a new coach is added, it is attached at the end. No need to move other coaches. Same in linked list, new node is added by changing the links. No shifting like an array. In removing a coach, if one coach is removed, other coaches are not affected. Only links are updated. Same in linked list, delete one node, only pointers are changes. So similar examples are there. There are music playlist. A playlist, each song is a node. Each song points to a next song. That is song 1, song 2, song 3 and etc. In adding a new song, just attach it at any place. No need to shift other songs. In removing a song, just change the link. Playlist continues smoothly. So there are some other examples such as browser history. So why linked list is important? That is because data is dynamic, size is unknown, frequent insertion and deletion happens. So in linked list are used in operating system, memory management, databases, navigation system, task scheduling. Linked list is used because it grows and shrinks when needed that we have already seen. So now what is a linked list? A linked list is a linear data structure where data elements are stored in the form of the nodes. Each node contains both parts, that is data parts stores the values and the link part stores the address of the next part. Unlike the arrays, linked list elements are not stored in a continuous memory location. In C++, a linked list is a linear data structure that allows us the user to store data in a non-contiguous memory locations. A linked list is defined as a collection of nodes where each node consists of two members which represents its values and a next previous pointer which stores the address for the next and previous nodes. As we know already, why linked list? That is the problem with arrays. Though what are the problems of arrays? Fixed size, memory wastage, insertion and deletions are costly, requires shifting of elements. So what is the solution with the linked list? So dynamic memory allocations, easy insertion and deletion, efficient memory usage. These are the advantages and the solution for linked list that is provided for the problem array. What are the types of linked list? There are four types of linked list. They are simply linked list, doubly linked list, circular doubly linked list. Let's see what are all they and how it works practically. Initially, we see about the structure of a node. A node is a fundamental unit of a linked list. It is a self-referential data structure that contains both data and a reference to another node. So what are the component of the nodes? Data field and link field. In data field, it stores the actual information of list element. can be a type of any data type, that is int, float, character, or even another structure. In link, that is the pointer field, it stores the memory address of the next node in a linked list. It establishes the logical connections between the nodes. Let's see the structure of nodes. It indicates as structure node open parenthesis int data. The int data represents the data field. Next, we have mentioned the node star nest. It indicates link field, that is pointed to the next node. Then we have to close the braces and then semicolon. So it is the basic structure of a node. Let's know more about the structure of the nodes. The pointer field makes the structure self-referential. Nodes are allocated dynamically using heap memory. The last node's link field is set to null, indicating the end of the list. A separate pointer called head stores the data of the first node. Let's see the types of the linked list. First one is simply linked list in C++. The simply linked list is the simplest form of linked list in which the node contains two member datas and a next pointer that stores the address of the next node. Each node is a simply linked list is connected through the next pointer, and the next pointer of the data node points to null, denoting the end of the linked list. The following diagram describes as the structure of a simply linked list. This is the simple structure of simply linked list in C++. The node contains a point to the next node means that the node stores the address of the next node in the sequence. A single linked list allows us the traversal of data only in the one way. Here we indicate one as a head and last one as a null. So after null there is no more data that are going to be stay. This is the simple structure of single linked list. So again we are going to see the structure. So here we have mentioned the structure to represent the simply linked list. So structure node, then open parenthesis, we are going to do a data field which can be of any type and count int data. Then pointer to the next node that we can mention as structure node star nest. Next one is doubly linked list. The doubly linked list is a modified version of simply linked list where each node of a doubly linked list consists of three data members, that are data, next and prev, that is can be mentioned as previous. The previous is a pointer that stores the address of previous nodes in the linked list sequence. Each node in a doubly linked list except the first and the last node is connected with each other through the previous and the next pointer. The previous pointer of the first node and the next pointer of the last node points to the null in a doubly linked list. So we can see the structure of a doubly linked list. Here is the structure of doubly linked list. So in starting we have a head. It includes as previous and next. So that then it continues as 2 and 3. These are the nodes. Each node that contains as previous and next that are linked to each other. The doubly linked list can be represented as pointer to the first node where each node contains data, that is, its actual information is stored. Then next pointer stores as the address of the next node, and in prev stores the data of a pointer address of a previous node. This is the doubly linked list representation. So similar to the first one, here we are going to include only one, that is the previous node. So initially we have to represent the doubly linked list, that is touch node, open parenthesis. Then we have to include that the int data. So that is the data field. The next one is touch node star next. That is it pointers to the next node. And then we have included the touch node star previous. So next type is circular linked list representation. The circular linked list is almost same as a simply linked list but with a small change. In a circular linked list, the next pointer of the last node points to the first node of a linked list rather than pointing to the null. This makes this data structure circular in nature, which is used in a various applications like media players. So we can see the circular linked list. So this is the representation. Here we have continued from last one to the head. That is, you can see that here we have the last node. It have mentioned the next and it indicates us to the first header node. So this is called as circular linked list. So what is the representation of circular linked list? It is similar to the simply linked list. First one, it represents as a circular linked list. So structure node, open parenthesis, then we have given the data field, that is the integer data. Next we have mentioned pointed to the next node, that is structure node star next. So in circular linked list can be represented as a pointer to the first node where each node contains its data and next. It actually stores the information where the data. Then next it pointers to the next node and the last node. Next is pointed to the first node of the linked list. Last type, circular doubly linked list. A circular linked list is called a circular doubly linked list in which each node has a two links connecting it to the previous node and the next node. In circular doubly linked list, two consecutive elements are linked or connected by a previous and next pointer, and the last node points to the first node by next pointer, and the first node also points to the last node by the previous pointer. Here we can see circular doubly linked list structure. So it starts from the first node, it has the data, and the last node is the data. So in the middle of the both data, we can see the previous and next that indicates us an arrow mark from the first node to the next node. So that it continues in the upcoming nodes also. Then from the last data, it moves to a first data, and from first data, it moves to the previous, that is the last data. So this is the structure of circular doubly linked list. So in circular doubly linked list, the main feature is that the circular in design. So doubly linked, each node is a circular linked list has a two pointer, that is next and previous header node. A circular doubly linked list has a header node which is frequently used to make execution of a certain operations. So what are the applications of linked list? In dynamic memory allocation, linked lists are used to keep track of free and allocated memory blocks. Linked lists are used in text editors to implement undo and redo operation. Linked lists are used to implement adjacency list for the graph data structures. It also used to implement the fundamentally data structure like stack and queue. Then what are the advantages of linked list? We have already seen that. Here we can see in a detailed manner. Inserting and deleting node is efficient because no need to shifting like array. Linked list have dynamic in size which allows us them to grow or shrink during the runtime. Memory is utilized more effectively as linked lists do not require a pre-allocated size, reducing wasted space. Efficient for those operations where we need large or frequently changing datasets. Linked list used non-contiguous memory block, so it is useful for those applications where the memory is needed. Then what are the disadvantages of linked list? Direct access to element is not possible in the linked list. It requires traversing from the start to reach a specific position. Each node requires extra memory for storing a pointer. Linked lists are more complex to implement and manage. Pointers can lead to bugs, memory leaks, or segmentation faults. These are the disadvantages. To conclude, a linked list is a powerful and flexible data structure used to manage the data and store the data. The linked list concept is the same in every programming language, only the syntax changes, not the idea. For example, in C++, we use pointers. In Java or Python, we use object references. But the structure and the working remains us the same. Thank you for listening and see you in the next lecture. Thank you everyone.